Okay, folks, how's it going, everyone? I miss you all, and it's been really tough being at home and not at school. I hate missing school, but I have to take the time to recover, and did not plan on being out this long, but I will return on January 2nd, and I'm looking so forward to that. You'll all be finished with college applications, so you'll be much more relaxed, and you can just focus on learning some stuff, so that'll be fun. I wanted to answer some questions and just go over a few things with you here. Try to do it quickly. I can sometimes get very, chatty here, but I'm new to this YouTube channel thing, so I'm, it's not as flashy as other, so you don't have to click to subscribe, don't worry. Okay, so some questions here. All right, so we do have some questions from both classes, so just getting going here. When a question asks how to design an experiment, do we need to include the 4 elements of an experiment and other things? In other words, what should we include in our description? So this is a big question to start, and I'm kicking off the video with this because this is really kind of the biggest thing that I saw there was a problem with when you did this 4-2 designing experiment sheet. First of all, I have to apologize that the whole side was missing, so you probably kind of felt that. You only received this part and this part, and you never received this randomization part here. Yes, it is very important for you to convey the 4 parts to every good experiment. And so you can do that by making a flow chart, right? So let me just remind you what that was, and this was from the 2000 AP number 5, so if you want to look at that online. And it was about cholesterol level. It said high cholesterol level in people can be reduced by exercise or by drug treatment. A pharmaceutical company has developed a new cholesterol reducing drug that is currently available on the market. Volunteers who have a history of high cholesterol and who are not currently on medication will be recruited to participate in the study. So they wanted you to make the make it better by blocking, but you didn't have a chance to do the completely randomized design. So let me show you what that would look like, and we'll compare it to the randomized block design. Okay. Excuse me, I just need to let my dog out. He needs to, All right, I'm back. So, completely randomized design. So if you wanted to do a completely randomized, then there would be no blocking, right? So let's suppose that you had, 50 volunteers for this, right? You would show that you're going to randomize from the beginning. And you're going to randomize into 2 groups, right? So group 1, let's say, would have the old drug. Group 2 would have the new drug. And I would also have a placebo group or control group. Now, I know that some of you take psych. The placebo group and control group in stats is really one and the same. It's the lack of treatment, right? And so you could have, let's say, 3 groups, okay? And so it's completely randomized, you're not blocking at all. And so you would want to then, from that point, you'd want to say what you're gonna do to them, right? So you're gonna give them this particular drug, and what are you going to measure and compare. Measure cholesterol level and compare. Okay. And so you want to say how many you have here. So let's say, I don't know, I forget what I said, 50, but let's say I have 120, and I'm going to put 40 into each group. Okay. So when I look at this experiment, right, I want to be able to use those 4 elements as a checklist, right? So what do I have in this experiment? I have control in the form of a control group, right? I have the randomization, which I'm saying I'm doing that from the beginning. Some questions ask you to explain the randomization process. I would, if I wanted it to be really complete, say exactly how I would do it. So I would label the 120 volunteers. Then I would use random integer, if that's okay with them. No repeat, 1, 20, 1, 120, 40. And those 40 people would be placed into group 1, right? Random integer, no repeat. And then I would take the remaining people, right, and place the next 40 in group 2 and the remaining in the control group. Or you could have, shifted these groups. So I've got my control, my randomization, my replication is in the fact that I have 120 volunteers, and then the comparison. So I've got the comparison here. I'm not just going to say compare, which I saw on many people's papers. I'm going to say exactly what I'm comparing. So I'm measuring cholesterol levels and comparing, or you could just say compare cholesterol levels. Be very specific here. I could probably add more. I'm running out of space. But make sure that you've got all 4 things, right? Some students use CRRC to remember: control, randomization, replication, and comparison. Gotta let my dog back in. Come on in. Okay. All right, so that is a completely randomized design. So in that 4-2, you had to then design an experiment that would improve it by incorporating blocking, right? So how would that look different? Moji. Okay, this is fun. So if we wanted to incorporate blocking, first of all, we need to decide what variable are we going to block for. Think about that. So what variable are we going to block for it? They kind of imply in this problem, in the 4-2 focus handout, that exercise might also affect the cholesterol level. And so, that's kind of a nudge, nudge, wink, wink. This is the one you should use. but there's so many other variables you could have blocked for. You could block, again, for weight. You could block for age. You could block for diet, right? Type of diet, vegetarian. And so there are so many other things. They kind of want you, I think, to use the exercise, right? So you'd start by saying, block for exercise level. Right, there's nothing random about this, right? So people who exercise, so exercise, no exercise. Right, and maybe you've got different levels of exercise. And then from there, you basically have the same experiment I just outlined coming off of this, right? So then you've got the randomization, right? Write out the whole thing. Then you have group 1. Group 2, and you'd say what each group is getting, right? Be very specific. And then within, right, you would say compare cholesterol level. Right, and you do the same thing here, right, and you'd compare. Right, again, be specific, cholesterol level. Right, do not just write compare. Tell me what you're comparing. And then from there, you don't want to ever compare these two groups. You could say combine results. Combine results, right? But you don't want to ever say that you're going to compare the response from this block to the response from that block. Because you've just said that this has something to do with the response. So we shouldn't compare it. We should do it differently, right? We should organize it in this way. So you never want to compare one block to the other, okay? So again, here we have control in the form of blocking and a control group that receives a placebo. We have randomization after we blocked. We have replication, right? So the blocking here, I don't know how many I'm going to get within each group, right? Because I don't know how many in my 120 that exercise is. It's not going to be equal, that's fine. Then we have the comparison specifically within blocks, right? We're blocking for the variables we know about that have an effect on the response. We randomize for the variables we don't know about that might have something to do with it. So that's why it's very important to have that randomization after we blocked. Okay. So this would be my expectation, right? Be very specific as to what each group is getting. Tell me what you're comparing. If you're randomizing, if you want to make sure you've got everything clear, explain how you explain the process. Okay? And remember, you're always assigning subjects to treatments. You never assign treatments to subjects. All right? It's always subject to treatments. Okay? All right, so that was a big question. So we should all thank that student who asked that question, because that was a really, really good question. All right. All right, I gotta let my dog back in. All right. Okay, next question. What's the difference between Rosenthal effect and Pygmalion effect? It looks like they were basically the same effect, so there really is no difference. I just wanted you to look at other effects besides the placebo effect. I thought that they were very interesting, and I wanted you to spend some time looking through those. You should kind of be familiar with those, be able to identify what it might be. You don't necessarily need to name it, right? Someone asked that in the questions, you need to name it. The names aren't as important as you kind of understand how these effects could occur, okay? And then another student replied to that student's question, also, what's the difference between the John Henry effect and the Hawthorne effect? So the John Henry effect is a little bit different from the Hawthorne effect, because the John Henry effect is when individuals in the control group know they're in the control group somehow. They know they're getting a placebo, and they're really trying to overcome that, you know. So if you know the story of John Henry, you might make sense as to why they call it that. But it is a little bit different, because the Hawthorne effect is basically not that the individuals know that they're in the control group, but they know they're being observed, and so that changes their behavior, right? Think about when a teacher is observed by administration. Sometimes does it seem like their behavior changes a little bit? Do the students' behaviors change, right? So just when you know you're being observed, just by that knowledge, you're going to change your behavior, which might affect the response that they're trying to measure. Okay. Next question, what is an example of the types of questions we would be asked? Can we have a sample question with like a model answer with all the parts we need to include? So that's basically this, right? So all of the AP questions that I gave you, those 4, are great to practice. You also have, as I said, the Chapter 4 AP test in the textbook that you can do. I'll scan that and also scan the answers. It's in your book, but we don't have enough books to go around, right? And another question was, how can we tell the difference between random sampling and random assignment? And how do we know if a study experiment has either? 2A on the quiz 4C. And another student also emailed me about that handout. So let me look at that. All right, so this was the classwork 4-3 handout that you folks had. And so the difference between random sampling and random assignment. So, you know, the fact is that, you know, random sampling is rarely going to occur from a population. So that's what I talked about in the PowerPoint, that, you know, inference about a population is very, very rare, because you can't take an SRS from the population and then experiment on them, right? That's not ethical. They have to be willing to participate. And so unless it says clearly SRS from the population of interest, it's not a random sample from the population, okay? So specifically the student was asking about 2A on the 4-3C. It says a marketing executive who wants to gauge reaction to a new packaging design for a popular brand of cookie places the new packages in 45 randomly selected grocery stores in a large city and compares sales of the cookies to sales of the same cookie with the old packaging in the previous month. So it does say that they're going to place the new packages in 45 randomly selected grocery stores. And so that certainly is, you know, a random sample from the population. I mean, I don't think I would stress too much about this. It's more about the randomization part, because in reality you're not going to have an SRS. So I mean, it says randomly selected grocery store, so there you go. All right, and then another student had asked about 4-3B, B and C. So does blood type determine your personality? In a study aimed at answering a question, a random sample of 100 adults were given a personality test. So again, it says a random sample, so that means that I could provide an inference about the population. I don't know how realistic that is, but that's what it says. And then for part C, does the calculator improve understanding of mathematical concepts, or all 200 fifth graders at a school are randomly assigned to one of two groups? So that's a convenient sample. I went to an elementary school and I looked at the 200 fifth graders, right? And I am then using a randomization process based on that convenient sample, right? So in that case, because there's only randomization, there's not an SRS, I can perhaps find an inference about a cause and effect relationship if I have a good experiment, right? But I can't provide an inference to, you know, all the fifth graders in the country, okay? All right, so that does it for the questions in that class. Let me switch to the other class. All right, and go to that discussion. All right, so question here, what's an inference procedure? An inference procedure is basically a hypothesis test or a confidence interval. So it's the calculations basically that will come after you have your data, right? So this chapter is getting you ready to create a data set that will be useful for an inference procedure, which will be the focus of the second half of the school year. So an inference procedure is a hypothesis test or a confidence interval. Right? You're seeing confidence intervals right now all over the place if you look at the presidential race. You know, how many points are they at this point? Are they up or down? And you know, the percentage point that they get is really just the center of a confidence interval. And the confidence interval is sometimes plus or minus 3%, plus or minus 5%. So let's say if someone has a 23% a rating, meaning that 23% of voters surveyed would intend on voting for them, then that is an estimate. That's the center of a range of possible values that the confidence interval provides. But that's kind of getting ahead of ourselves. All right, let's see. Will we have any Table D questions on Friday? Yes, we will. We certainly will. So make sure you know how to read Table D. And I think you had some of those in the homework. Could you go over the different types of design experimenters can use in a study? This is a huge question. Basically, rewatch the two PowerPoints. There are three kinds, right? There is a completely randomized, which I just did earlier, which has no blocking, a randomized block design, or match pair design, right? Match pair is a special type of blocking, and match pair is when, if you think of the boot problem I gave you, the AP question, I love that problem. Not too many students get that the first time around. That it's possible to do a match pair with yourself, meaning the person could wear a boot of each kind and walk around and see what the damage is to each boot. Because it's possible that you spray it and it's not changed, right? I don't mean like a brown boot and a black boot, right? So if they're taking a pair of boots, they're spraying one of them with some kind of protection, I think it was. And so you're able to not know, and you're able to be both the control group and the experimental group. So that's different from a match pair with another person. Let's say that they're doing a clinical trial between two particular drugs and they're matching one subject with someone else who's very similar. So maybe I would be matched with a woman of my own age, about, you know, my similar medical background, similar weight, you know, all of that, to be matched with someone else, because I can't take both drugs. You know, there would be too much confounding there. So match pairs is a specialized form of blocking, and blocking is always better than not blocking. If you can block with yourself, then that's great. Like if you had suntan lotion on one and placebo suntan lotion or some other form of lotion here, sunscreen, not lotion. So sometimes it's possible to do match pair with self, like in the boot problem. Sometimes it's not. Okay. Let's see, what other questions? Do you have any example questions? Well, you've received the AP questions. You also have chapter review in your textbook. And you have, as I said, the chapter 4 AP test that comes right after the review. And all the answers are in the back of the book. I will scan both of those and put them on the Schoology page so everyone will have a chance to work on those today in class. Okay. And then I just had a last minute question, literally 20 minutes ago. Could you go over the 2005 AP Stats Free Response Question Form B? Okay. Let's see which one that is. All right, that's the one about the mosquito repellent. All right, so 2005 Form B, it was a mosquito problem here. So essentially, they don't want you to do this here. So let's be clear. It says, suppose the study is going to be completely randomized. Describe a randomization process and identify an inference procedure for the study. So the randomization process, don't worry about the inference procedure because that, as I said, is the second half of the school year. You would just need to describe how you're going to assign the individuals to the bins, right? So you've got 100 people, so you would label them from 1 to 100. You would do random integer, 1, 100, 50. I guess you're going to take half of them and use one compound, half use the other compound, right? So 1, 100, 50, and then they would go with the current compound, and then the remaining would go with the old compound. They are trying to ask you now how it would be done using match pair. So remember that whenever you do an experiment, you really do need to have some kind of randomization. And so when you're doing match pair with self, which this is possible, right? It's possible to put one repellent compound on one arm, the other on the other arm, and then place both arms inside of the mosquito bin. This sounds like a wonderful experiment. And so, and then see how many bites you get on each arm, all right? Do not sign me up, please. I always get mosquito bites. So this is a good reason why to do this with the match pair, because some people do get bitten more often because your skin gives off whatever kind of scent where the mosquitoes like you. So you still need some kind of randomization. So the randomization would occur, the only way to randomize there is to randomize which arm you put the repellent arm on. So for each individual, right? You're going to assign them to a group where they put the new on the right arm, right? And the old on the left arm. And then the other group, you would do the reverse, right? So you would say 1, 100, 50, and you would random integer, no repeat, place those individuals in a group where they receive the new on the right, the old on the left, and then vice versa. Okay. And then lastly, question 3 from that says, which of the designs is better for testing the effectiveness of the new versus the current and justify? So remember, blocking is always better. When in doubt, block it out. And so you would want to talk about the fact that when you use a match pair, you are minimizing bias, right? You're blocking for the variables you know about that might influence the response, the number of mosquito bites, and so because of that, the match pair design would be better. Okay, all right, and that does it for questions from the discussion. All right, so let's go to my other questions that I had. All right, it says, I did a quick search on Google, Rosenthal effect just being another term for Pygmalion. Absolutely right. There's no real difference between them. You don't have to really know the effects by name, but you should know what they're about and why it might happen, right? So that was a question. Kind of already addressed that one. Okay. Alrighty. I'm sorry, this is going kind of slow, guys. I just want to make sure I've answered everyone's questions here. Alright. Alright, now I know I had a question on this problem, and this is another one of the infamous problems. The question was, I believe, why is blocking scheme A better than blocking scheme B? So, yep, here it is, I believe. For question 4A, which is blocking scheme is better, the correct answer is A, but I don't understand how it's better since A gets more exposure to the trees than block B. Right? So, yeah, you're absolutely right. Right? So this was the problem. Right? And A was the better blocking scheme. And the best explanation is when you block, you're trying to eliminate variables that might affect the response. And so I think you're planting trees here. So you're right, these trees have similar exposure to the shaded area, right? So when you block, like here, you're blocking because you're trying to separate out that variable. So everyone in this group is very homogeneous, right? They all exercise, right? So same here. All of these trees are going to get the same exposure. So you're eliminating the fact that if you were to just randomize, right, in B, right, if you randomize in block B, then it's possible that a particular tree ends up both here and here, right? So they're going to get more sun, so they automatically have an advantage, right? And so when you block, you're trying to create groups that are homogeneous. And this group is not homogeneous here because they have different exposure, right? It's like putting people together that exercise and don't exercise and see what happens when they take this medication, right? The people who exercise are going to have a different response than the people who don't exercise. Just like in this problem, the trees that have more sun exposure are gonna have a different response than the trees that are in the shaded area. Okay. I hope I answered everyone's questions. And I just wanna make sure that I covered everything I wanted to. Okay. The only other thing I wanted to mention was this activity that you did on the chocolate studies, okay? I didn't really go through and read every single word you wrote, I just kind of scanned them. But the important points were that in study one, and many of you made this comment, that is just an observational study. So that's out the window as far as creating a cause and effect relationship. There was so much going on there. You know, the mothers are rating their own infant's temperament, so there's a whole lot of bias going on there. In study two, I did want to mention the following. That was a study where each subject consumed a cocoa beverage containing the flavonoids, which is basically the cocoa, for 5 days. And they were measured on day 1 before they drank it and on day 5. So that's a matched pair, right? That's a matched pair, but that doesn't have any control really to help with comparison. You're comparing the person to themselves, but it could be made better, study 2, if you had a group of individuals who received, if it was possible, to create a placebo cocoa beverage. As I talked about in the 4-3 PowerPoint, sometimes, you know, people can really kind of figure out that they're receiving a placebo, but if you could have an imitation cocoa beverage and do the same thing with the comparison, you would make this much, much better. And so for those reasons, I would agree with those of you who chose study 3, right? Study 3 had it all. It had control, it had randomization, replication, and comparison, okay? So you're getting these back today. I hope all the papers are passed back so you can look to see what you wrote again there. But all right, so I think I covered all the questions. If I didn't, then you can send me a Schoology message. I'll be on the couch where I am every day, and I will have my computer in hand during your classes, so I will try to quickly respond for you. But I wish you well on the celebration. I guess it'll be tomorrow by the time you see this. And just to go over the format, so I don't know if you made it through this long video enough, you deserve to have a few little tidbits of information. Okay, so again, there will be short answer. Okay, 2 or 3 of them. One of them will be, what is an SRS? I ask it every year. All right, most students give me half the definition. They say every individual has an equal chance of being chosen, but they leave out the other half, the fact that every sample of size N has an equal chance of being chosen. You've got to know what an SRS is, right? The other methods of sampling in stratified and cluster, you know, you might have an equal chance of being chosen, but every sample of a particular size does not have an equal chance of being chosen. So make sure you know what an SRS is. That's definitely going to be one of the few short answers. Make sure you know all the different sampling techniques. Students often get confused between cluster and stratified sampling. Right, they are random sampling, but it's not a simple random sample. So make sure you know the sampling methods. Make sure you know 4 parts to every good experiment. Make sure you know the difference between observational study versus an experiment. Takes one word. Begins with a T. Treatment, right? If you don't see a treatment, then it's observational study. An experiment has a treatment of some sort, okay? So there'll be a few short answers, right? Some of those. And then part 2 will be open response. Okay, there will be 2 AP or AP-like questions. Right. And then part 3, right, because these are a little bit quicker than like the computation, like the full AP computation questions. And these might have, it might be about experiments, about sampling, or about bias, right? Is there bias in the sampling or bias in the wording? So there'll be 2 of those. And then part 3, you are gonna have multiple choice. All right, this section, there's a lot of vocabulary. And so I think I'm gonna put about 10 on there, right? Because this is gonna be quick, and this is gonna be a little quicker. So there'll be 2 points each, because I know that some of you don't like multiple choice. I don't want to make them 3 points each. 2 points each, and then, you know, other points here and there. But this is what it'll look like. Yeah, so practice chapter review and the AP chapter 4 in the book. The AP chapter 4 test in the book. All right. Sorry this was very long and not, you know, as entertaining as other YouTube videos are, but I did my best. I hope everyone does awesome on the chapter 4 celebration, and I will see you next year. Next week, by the way, look forward to chapter 6. I'm planning on doing a couple videos for you this weekend on chapter 6 to get you going on that. We really need to get moving on that a little bit before break. So you'll have some videos and some classwork homework for that. All right, take care. Have a good one, folks.